Hi guys, this is the section 2.3 lesson for today, which deals with graphing equations of lines, something that you're very familiar with. Your objectives are find the slope, y-intercept and x-intercept of a linear function, graph linear functions in slope, intercept, and standard form, compare linear functions to a parent function, this may be something new to you, and then interpret the meaning of the slope and y-intercept of a function. I'm going to go through this fairly quickly because most of this is review, but there are some new things that I'll cover a little bit more in depth. Alright, so slope-intercept form. In class we've spoken about this before, and most of you were happy with y equals mx plus b as the slope-intercept form. M represents the slope, as we saw in the previous lesson. B, y-intercept. Okay, y-intercept is where the x value in the equation is 0, where the line crosses the y-axis. Alright, so first of all, when you want to graph an equation using slope-intercept form, it first needs to be in slope-intercept form. In this case, the equation is already in slope-intercept form, so to find slope and y-intercept, very easy. I'll write it down for you. Y equals mx plus b. In this case, our m is 2 over 5, and our b, or y-intercept, is 4. Okay? So we've identified that, and now we can just go ahead and plot those points on the graph. So x-axis here, y-axis here, this is my slope, and this is my y-intercept. So you always start with a y-intercept b. Okay, you always start with b, and then you use the slope to complete and find the second point to make your line. Okay, so slope is 4 here, so if we go up 4, not slope, y-intercept is 4, so here's the y-intercept 4, and slope, please don't plot a point 2 over 5. Students frequently want to make this a point somehow, but that's not how it works. Remember, slope is rise over run, as we saw in the previous lesson, and so in this case 2 over 5 means from B, from my y-intercept, I rise 2 and run 5. So from my y-intercept, I rise 2 units, and I run 5. 1, 2, 3, 4, 5. And there's my next point. Okay? So all you need to graph a line is really 2 points. So let me try and see if I can make a nice line through these 2 points that actually works. Ooh, I missed it. Let me get rid of that line and start all over. Okay, so I missed it there. That's 4 and up 2 over 5. Okay, and let me try and put the line through there again. Alright, let's see if I can aim a little bit better this time. Oh, there it is. Okay, so there's your line. Done. You're done graphing the line. Okay, the next example, same idea, but first you have to put it in slope-intercept form. This is not slope-intercept form. Should be mx plus b. That's not what I have here. Okay, and so you notice the function notation, same meaning as y for all intents and purposes. So we just have to rewrite it first. So we say, okay, f of x or y equals, switch them around. I need to have mx in the front, negative 3x, remember the sign goes with, plus 1 in the back. Okay, so just swap these two around, and now I have mx plus b format, and I can just graph it. Okay, so the slope is negative 3, the y-intercept is 1. We always start with b first, okay, and plot that point. This is the y-intercept 1, and then use the slope. Now, slope is rise over run. In this case, I only have negative 3. You can just put it over 1. Okay? And that's your rise, and that's your run. And so you can still go from the y-intercept, go down 3 in this case, negative 3, down 3. Okay, 1, 2, 3 units. And over 1, run 1 to the right because it's positive. And if you connect these 2 dots, let's try that again. The line, let's try my aim. Ah, boom, better. And so there it is. Okay, just a quick review of graphing using slope-intercept form. All right. Okay, so let's move on. Now we're talking about parent functions and a family of functions. So a family of functions, or in this case we're talking about linear functions, so a family are all the linear functions you can draw, and the parent function is the most basic function, like the base function that all those other functions come from. And for lines, that function is y equals x or f of x equals x. Okay, y equals x may be easier for you to understand. And it looks like this. In other words, the slope is 1, the y-intercept is 0, y-intercept 0, slope is 1. Okay, you should be very proficient at graphing this line. If someone says to you graph y equals x, it should be something you can do without really thinking too hard about it. All right, and so that y equals x is the parent function, okay, the most basic function for linear functions. So I'll do one with you, and then I'll let you try the other one. I'll just put the answer up. So again, here, let's graph this and then compare it with the parent function. It means you're going to have to graph two things. We'll work on this in class with technology a little bit. We can use some programs to do this quicker, but we'll do it by hand here. So this is not slope-intercept form. We have to rewrite it again. So to put it in slope-intercept form means negative 3x plus 1. I rewrote it now in slope-intercept form. Here's my y-intercept, b, and here's my slope. But remember, slope, we want to have a fraction so we can graph it easier. So b is 1, and slope is negative 3 over 1, just like the previous line we had. And the question then is graph that, okay? And then they're asking you to compare this to the parent function. So we can label this. This is f of x equals negative 3x plus 1. Now compare this to the parent function. Now the parent function is y equals x, y equals x. Now y equals x, let me make some points here. Y equals x, of course you can see that the y-intercept is 0, there is no number, okay? And then the slope is 1, so up 1 over 1, and it does that all the way, all right? So if you graph this as a line, basically you're going from this corner to that corner, boom, okay? There's the line y equals x. And so when they say compare, how is this function different from the parent function? Well, it's different in that the slope is negative, so it's falling from left to right, and also the y-intercept has moved up 1. And so we'll do a lot more with this with transformations, but this is basically a transformation, and the slope is different, okay? And so if we do the next one, I'll just go ahead and graph this very, very quickly. The next one, the y-intercept is negative 3. Let me switch back to blue here for this function. The y-intercept is negative 3. The slope is 1 over 2, so rise 1, run 2, and then draw your line. Okay. Yeah, that's okay. I'll leave it like that. So this function is y equals 1/2 x minus 3, and the parent function, okay, the parent function is y equals x. Again, you should be very familiar with this line. It's always the same. Y-intercept 0, slope is 1, so you're hitting every point there, up 1 over 1, and make a line here. So basically from corner to corner, okay? And so this is y equals x, the parent function, and this is the function we graphed. If you compare them again, you can see that our function has moved down 3 units, and its slope is 1/2, it's not 1. So it's rising a lot slower than the parent function y equals x, and its y-intercept was transformed 3 units down. All right? Okay, so next one here is just a little word problem talking about decrease in value of a copier. Okay, so I'll read this through with you. The value y of a copier x years after it was purchased can be modeled by this equation. Okay. Graph the equation, describe what the y-intercept in slope represent, and use the graph to estimate value of the copier after 5 years. Okay, 3 things there. Let's do the first thing, okay? So let's just look at the function y equals 4,000 minus 600x. So this is the value of the copier is y, and x is the number of years after it was purchased. So interesting to think about, what would 400 mean and what would the slope mean? Okay, that's what they say, describe the y-intercept and the slope. So let's graph it first and then we can look at that. So if you graph this, basically you can find y equals mx plus b. You can do it like that. So let's do it like that since we're talking about slope-intercept form. Y equals negative 600x plus 4,000. Okay, and so if we put x down here, x again is number of years. So we can say years over here, right? And y is the value of the copier. So this will be dollars, right? And so basically we can use that same principle we used earlier to graph. So 4,000 would be the y-intercept. So I'm going to go ahead on my graph here and say let 4 blocks or 4 units represent 1,000. Okay, so 1,000, 2,000, 3,000, and we'll stop at 4,000. That is the y-intercept. Okay, and then time in years, they're talking about 5 years here, so it's probably fair to go with years as in units of 1. So I'm going to jump with years here by ones. I'll go every 2 blocks or every 2 units I'll call 1. So 1 year, 2 years, 3 years, 4, 5, 6, and let's go to 7. Okay, and so we take this information and we plot the graph now. Okay, we just draw the graph. So y equals that. This is the y-intercept. So the y-intercept, let me pick a different color. The y-intercept is 4,000. Here it is. Okay, and the slope here is down 600 over 1. So down 600 over 1. So if you go, here's 1. All right, so down 600 from 4,000 to 3,000. This is 500 over here. So down 600 will be just a little bit down, and over 1, that puts me over here somewhere, right? Somewhere over there, okay? And if you continue that, you'll see that it gets you to about 6.7 for the x-intercept, but we'll talk about that in a little bit. So let's just draw a line through that. Okay, let me pick the right color for the line. Let's just draw a line through those two, and gets you basically over there. All right, so that's fairly accurate sketch of this function. Okay, and so we've graphed the function, and now they say describe what the y-intercept and slope means. So y-intercept, it's easier to see on the graph, really means this is the value, y is the value of the copier. So this means in year 0, when I just bought the copier, the value of the copier was 4,000. So the y-intercept is the value of the copier, okay, when you bought it. When I bought it, or year 0, or however you want to think about that. And then what does the slope represent? So slope means for every year, the value of the copier is going down 600. Every year, the value of the copier is going down 600. Okay, so slope in this case represents the decrease in value. The decrease in value of the copier. That's what slope means in this case. Okay, then they're asking you estimate the value of the copier after 5 years on the graph. So your graph needs to be accurate. Do this with a ruler. After 5 years, the value of the copier on my graph looks like it's about 1,000, maybe 100. Okay, I think your textbook had 1,000 because they graphed it very, very accurately. When I did it on my paper, it was also about 1,000. But so on my graph, after 5 years, the value would be, let's say, after 5 years, the value on my graph looks like about $1,100. Okay, pretty close, we're estimating on the graph. All right? Okay, so rate of change we did last time. Interpreting what x and y, what y-intercept and slope represent is fairly important on a graph. Okay. All right. So next thing you've done before as well in Algebra 1 is standard form of a line. Okay, standard form of a linear equation. Remember, a, b, and c are real numbers, and a and b cannot both be 0. If they're both 0, then you're not looking at a function at all. Okay. So standard form. Graph the equation in standard form, but this time they want you to use the x and the y-intercept. Also a review topic from Algebra 1. So x and y-intercept, and I'll show you quickly again how to find that. So let me move this up a little bit. Let's get past the formula. Okay, and so here I'm going to graph this using the x and y-intercept. So let's just review. To find the x-intercept of a linear function, you set y equals to 0. So go in the function here, 2x plus 5, but change the y to 0. Okay, equals 10. So what I have here is 2x equals 10, and divide by 2x equals 5. All right, so this basically goes away. 5 times 0 is 0. That's what I have left here. So x equals 5 is the x-intercept. Okay, so x, y. And what does x-intercept mean? It's where the line or the function crosses the x-axis. So x is 5 is a point over here on the x-axis. And then y-intercept, to find that again, basically you set x equals to 0. Okay, so look at the function, make x 0, 2 times 0 plus 5y equals 10. So if x is 0, this basically goes away, and now I have 5y equals 10, and y is 2, if you divide that out. So the y-intercept, which is where the function crosses the y-axis, is 2. Okay, so here's my y-intercept, and we can just draw a line through that. Okay, draw a line, see if I can aim this correctly. Boom, there she is, fairly close. Okay, so there's your line. All right, same thing for this. You know, I've already done this before I started making my video, so I have the answer already. I'm not going to go step by step through this. I think you're good enough to do that. I'll just tell you that the x-intercept here turns out to be 4, and the y-intercept here turns out to be -6. Okay, so x-intercept on the x-axis at 4, and y-intercept on the y-axis at -6, which would put us down here. Okay, and graph a line through those 2 points, and let's aim that one. That gets you probably there. All right, so here is graphing from a standard form equation using the x-intercept, y-intercept to graph the line. You can do this any way you want to, but that's a quick way for standard form. Okay. All right, so last two here are the easy cases, but students frequently forget this and lose easy points on a test. I don't know why this is such a challenge for people, but yeah, people very, very often get this wrong. So it's a horizontal vertical line. So again, horizontal line has slope 0, vertical line has undefined slope, something that just reviewed from last lesson. Okay, so a horizontal line is x equals, no, sorry, a horizontal line would be y equals 4. Okay, so basically, again, you shouldn't really ever get this wrong. This is supposed to be a fairly simple question. Y equals -4 would be down here. Where is y equals to -4? Here. And to make this, to draw this function, it's not a point. This is a function. It's not a point. A point looks like this. Remember, it's an ordered pair. This is not a point. It's a function. Y is always -4. Okay, so you go on the y-axis and you draw a line. Y is always -4. That is the graph of y equals -4. All right, and x, same idea. x equals 1. So you go on the x-axis where x is 1, make a point, and it's not a point, it's a function, or this is not actually a function, but it's a line, and so you graph it this way. Okay? Don't get these wrong on a test, please, because they're so easy, they're 3 points. So y equals horizontal, x equals vertical. Okay? And just think, if the point is on the y-axis, you draw a line through the y-axis. If the point's on the x-axis, you draw a point through the x-axis, a line through the x-axis. Okay? Fairly simple. I hope this was useful for you, and if you have any questions, we'll talk about this in class, and we'll do some graphing using technology. Have a nice day, guys.